on As You Learn. Oops, gotta remember to share it first. If you go down, I added weekly checklist. And so this will show you everything you need to do for the week, and it will have all the recordings. So for this week, you have the introduce yourself, which is on the discussion board, and then you need to read the syllabus and do the homework for that. That's on As You Learn. And then you also wanted to get onto My Math Lab, and what you need to cover for My Math Lab is below, which was chapters O and R. O is for orientation, R is for review, and we're going to go over the review problems today and Friday. If you notice here, the group assignment, I'm not having one this week because I want to review as much as we need to, because next week we want to start chapter 1. And that way, I think the review is more important. So we'll do most of the review today, the rest of it on Friday. These two here, videos for the week, these are problems similar to what we're going to do in class today and Friday. If you need more practice, then watch the videos and just fast forward the ones you know and do the ones you don't. That's up to you. This was when I had an strictly asynchronous class. They were all online. But the videos will help if you need more help. The Monday recording, my computer overheated for some reason in the car and it didn't download it. But my noon class was the same thing. So you could watch that one if you missed class Monday. Then my Tuesday class and then my noon Wednesday is up here already. So I will just keep adding to them for the recordings for the week. So anytime you miss a day, this is where it will be. Any questions on that? Okay. If there isn't any questions, I will start reviewing. But was there any questions? Okay. It starts out with just combining like terms. And if you do need me to record another, just let me know. Okay. When it's just an addition sign, you can just drop it and combine like terms. Because you could think of it as a +1, but when you distribute, it wouldn't change anything. Now, to be like terms, they have to have the same variables with the same exponent. So notice there's only one x squared term. This one is not x squared. So it can't combine with anything. But then this minus x and this 2x, they're both x to the first power. We can combine them. When there's no number, you can think of it as a 1. So 2x minus 1 would be a +1x. And you don't have to show the 1, but if you put it there, it's not wrong. Then the last two are constants. +5 and a +2 is a +7. Any questions? Okay, let's try a subtraction. When you're subtracting, it is important to distribute that negative because this will change the signs of everything in the parentheses after it. If you want to think of it as a -1 and distribute it, you can. If you want to just change the signs inside, you can do that also. I'm going to rewrite it. So when I distribute it, we can drop the parentheses. Negative times 3x makes it a -3x squared. Negative times a negative is a positive 7x. And then negative times a negative times the positive 1 makes it a -1. Then you can combine your like terms. 2x squared minus 3x squared. Combining the numbers in front makes it a -1x squared. 5x and 7x. 5 plus 7 is 12x. And a -1 and a -1, same sign, add them and keep the sign. Any questions on combining like terms? Okay. When you're multiplying, you just multiply them. You don't need to worry about like terms. And so this is a multiplication. I would multiply 2x times both terms. Terms are broken up by addition and subtraction. So this is two separate terms. Multiplying the first two, 2x times 3x. 2 times 3 is 6. And x times x, you add your exponents. So 1 and 1 makes it x squared. Then we take 2x times 6. 2 times 6 is a positive 12. And there's no x to combine, so it just stays x to the first. If you need me to slow down at any time, let me know. Since it is a review, but if you need me to slow down, we will. Or if you need another problem, just say show another, please. Any questions on that one? This was one term times a binomial. If you have two binomials, then you need to multiply 2x times both terms and 4 times both. When they're both binomials, like this one is, you probably learned the term FOIL, where you multiply the first two, outside two, inside two, and then the last two. So if we multiply the first two, 2x times x, 2x squared. The outside two, 2x times a -5, -10x. Inside two, and the last two. Any questions so far? Now, when we look at this, we have 1, 2, 3, 4 terms. But these two middle ones are like terms because they're x to the first power. So we can combine those. Bring down the 2x squared. Combining these two, a -10 plus 4 is a -6x minus 20. These are not like terms, so you cannot combine any further. Any questions on that one? Now this one really makes you work with fractions and your understanding of them. We don't run into this too much, but it's a good review just to make sure. So we would need to FOIL it because we have two binomials. When you're multiplying fractions, you just multiply straight across. So when we multiply these first two terms, 3/5 times 2/5 multiply across. 3 times 2 is 6. 5 times 5, 25. And then the x times the x is x squared. So that would be multiplying just the first two. Then we multiply the outside two. Again, multiplying straight across. 3 times 5 is a negative 15. 5 times 3 is 15 xy. First the outside. The inside two. Again, multiply straight across. 2 times 2. So positive 4 over 3 times 5 is 15 xy. And the last two. 2 times 5, and it's positive times a negative is a negative. 2 times 5 is 10. 3 times 3 is 9 y squared. Notice again the middle terms can be combined. That's why you could reduce this to a negative 1, but when you're combining fractions, you have to have the same denominator when you're adding or subtracting, and that's why I left it a 15. Because these are the same denominators, we can just combine across the top. So we have our 6 over 25x squared, and then 15, a negative 15, and 4 is a negative 11 over 15 xy, and the last term, negative 10 ninths y squared. Any questions on that? Okay, so we won't see this very often, but you do need to be able to work with your fractions. Okay, with this one, notice they're exactly the same except for the middle sign is opposite. These are called conjugates. When you multiply them, the two middle terms cancel out. And we use it a lot for limits to infinity. Trying to think what else we might get into with it, but it is used for a lot of different things. Oh, square root reducing. So when we FOIL this, notice if you multiply the first two, you get x squared. Outside, we get a negative 2x. Inside, we get a positive 2x. And the last two, 2 times negative 2 is negative 4. Why does it keep doing that? Notice the two middle terms, negative 2 and a positive 2, those cancel. And just leave the x squared minus 4. Any questions on that one? The biggest thing you want to be careful, the most common mistake here, x squared or x plus 6 quantity squared, is students want to put x squared plus 36. But you're missing some terms when you do that. Because remember, squared means to take something and multiply it times itself. So if we just square the first term and the last term, we're losing the two middle ones, the outside and the inside. So when we FOIL this, we have x squared plus 6x. Multiplying the inside, another plus 6x. And the last two, 6 times 6 is 36. Combine the middle terms, x squared plus 12x plus 36. So if you only square these two, then you're losing that middle term. Any questions on that? Okay, let's try the opposite. Let's try and factor. Now, when you go to factor, the first thing you want to do is look at the terms, and in this case, there's 3 of them. Is there anything we can factor out of all 3 terms? Anything that divides into them? Anyone?
2.
We can pull a 2 out because 2 divides into all 3 terms. So we divide 2 here, we have x squared. Dividing 2 from this one, we have 3x. And dividing 2 from here, we have 2. So one way of factoring is to pull out what they have in common. And you always want to try and do that first. Now we want to see, because this is x squared, we may be able to factor further. And there's no number. Notice there's no number in front of the x squared because we pulled the 2 out. When that's the case, then you can multiply to get 2 and add to get a 3. So what 2 numbers can we multiply to get 2 and add to get a positive 3? Anyone?
2 and 1.
Because when we multiply them, we get 2. When we add them, we get 3. So that will factor into x plus 2 and x plus 1. And so then this would be completely factored. You can use this format as long as the value in front of your x squared is a 1. So when there's no number in front of the x squared, you can factor this way. Okay, how about this one? 4x cubed plus 10x squared minus 6x. Is there anything we can factor out of it? Do they have anything in common?
2.
Yep, they have a 2. And how about the variables? They all have, yep, they all have an x. When you're factoring out, you have to take the x to the lowest exponent. So we could pull out, I'll put it down here, a 2x. So if we pull out 2x, we're left with 4 divided by 2 is 2. We're pulling 1x out, so it leaves 2 of them. We have 10x squared. 10 divided by 2 is 5. We're pulling out 1 of the x's, so it leaves 1. And then negative 6 divided by 2 is a negative 3, and we pulled that x out, so it's just a negative 3. Any questions on that part? Now, since there's a number, notice this one was just a 1. This one has a 2. When there's a number in front, you cannot just use this process because there's a value in front. There's a couple ways you can do it. One is trial and error. One is factor by grouping. One is a table. My son was showing me they learned this year. I think it's more time consuming, but he likes it. And then there's also an X. If you are comfortable in factoring, then do it whichever way you learned. I think the X from tutoring students in high school, I think the X worked the best and was the easiest to understand. So you only need to use this process if your squared term has a value in front that's not 1. Then you want to multiply your first and last term. So 2 times -3 gives me a -6. And we want to add to get our middle number, just like we needed to add here for the middle number. So instead of just using that last value, you have to use the first and the last. So 2 times -3 gave me the -6, and I want to add to get 5. So I need to find two numbers that when I multiply, I get -6, but when I add, I get a +5. Anyone? So think of the things that will multiply to a -6, like -3 and 2. But that doesn't add to a +5. It adds to -1.
6 and -1.
There we go. 6 and -1 will work because when we multiply, we get the -6. When we add, we get a +5. Any questions on that part? Okay. Now you need to do one more step. This value here, it needs to divide into both of these. We didn't need to do that up here because it was a 1. But you divide each of these by your leading term, which is 2 in this case. So you use whatever the leading term is. This will reduce by 2. So I get 3/1. This one doesn't reduce. So I divided by my leading term, and then if it can reduce, you want to reduce it. Then to write the factor, put an x in the denominators. So we have this 2x I just brought down, and then this will factor into 1x plus 3 and 2x minus 1. It seems a little strange at first because I know the first time one of my students showed me it, I thought it was complicated, but when I see how long it can take to do trial and error, I think it works out really nice. We'll try another one. Is there any questions? Okay, so we want to factor 6x squared plus x minus 2. Now it's up to you which way you want to do it. If you are comfortable factoring a different way, then go ahead and factor it that way and we'll make sure we have the same answer at the end. But if you want to try the x, go ahead and try that, and then we'll go over it. Are you getting 3x plus 2 and 2x minus 1? First thing I did was took the 6 and the negative 2 and got a negative 12. So I need to multiply to get negative 12. And then I want to add to get my middle term, which is a 1. Remember, when there's no number, it's a 1. So I chose 4 and negative 3, because when you multiply them, you get the negative 12. And when you combine them, 4 minus 3 is a positive 1. Any questions so far? Then you want to divide by the leading value, which in this case was a 6. In this case, both reduced. This one reduced by 3. And I got a negative 1 over 2. And this one reduced by 2. And it gave me a 2 over 3. Then I put the x with it, 3x plus 2. And this one, 2x minus 1. 2x minus 1. Any questions on that? Do you want to do one more? Anyone?
Yeah, do one more, please.
Yeah. I mean, this is definitely a part where students make careless mistakes, so I think it's important. 2x squared plus 6x plus 4. Oh, wait, no, that one's just, we did that one. Sorry. I thought I had another one written. That will work. Okay, 5x squared plus 6x minus 8. So go ahead and try that one. You're getting 5x minus 4 and x plus 2. So we took the 5 times the negative 8 and got a negative 4. We need to multiply to get negative 4. We need to add to get the middle one, which is a 6. So I chose 10 and negative 4 because when I multiply, I get negative 40. When I add, I get a positive 6. Then I divided by the leading term, which was a 5. This one reduces by 2, or I mean by 5, and it gets a 2. And that's where I got the 1x plus 2. This one doesn't reduce, so it becomes 5x minus 4. Any questions on that? Okay, so that is factoring with 3 terms. We do have a case where you factor with 2 terms, and that's when they're both perfect squares, because if we have a squared minus b squared, it factors into a minus b and a plus b. So if you have 2 perfect squares, if you can write them as a quantity squared, then you can drop those squares off and write it as a minus b, and then its conjugate a plus b. We had x squared minus 4. 4 is a perfect square. What that means is we can write it as 2 squared. So 2 squared is 4. And we can drop off our squares, and it's x minus 2, and then its conjugate, x plus 2. We had 25x squared minus 9. 25 and 9 can both be written as perfect squares. 25 is 5 squared, and then x squared, minus 9 is 3 squared. So you have 2 terms, and they're both can be written as perfect squares. Drop off the squares, 5x minus 3, and then write its conjugate, 5x plus 3. Any questions on that? Okay. Now, this is a minus sign. If there's a plus sign, even though they're both perfect squares, it's not factorable. Until we learn about imaginary numbers. I don't think we get into those in this class, but so this plus sign is not factorable. It has to be a minus. Any questions on that? Now this one deals with factoring and reducing. When you have a fraction and you're trying to reduce, and we have 4 terms, 2 on the top and 2 on the bottom. If something were to divide into all 4 of them, you could divide it out. In this case, it doesn't. There's nothing that goes into all of these. But we could factor the top and the bottom, and maybe something else will reduce. So if we pull a 2 out of the top, when we pull the 2 from here, we're left with an x, and negative 6 divided by the 2 is a negative 3. And factor out of the bottom. What can we factor out of the bottom, or the denominator?
5.
5 goes into both terms. So when we pull the 5 here, we have an x. Negative 15 divided by 5 is a negative 3. Notice the 2 terms are the same. The quantity has to be exactly the same, and if it is, you can cancel them, and you have 2/5. Any questions on that? Um, okay, go ahead and do this one. Now you could factor a 2 out of the top and a 2 out of the bottom. And then notice the 2 2s will cancel. Another way of doing that, if you look at all 4 terms, a 2 will divide into each of them. And so then you can just divide each term by 2. So that here the 2 2s cancel and leave x. 6 divided by 2 is 3. 14 divided by 2 would be 7x. And -4 divided by 2 is a -2. You're going to get the same answer. It's just another way of doing it. You're kind of skipping this part. You're just putting it here. So when something can divide out even out of all of them, this is a case you can do. Any questions on that? The biggest thing is making sure it's all of them. One thing that usually happens, like here, this is reduced by 3, but you can't just reduce here because it has to go in all 4. So remembering that will help. Any questions on that? Any questions so far? On this one, there's nothing that goes into, notice there's 6 terms. But we can factor the top and the bottom, and then maybe one of the factors will reduce. So you want to factor the top and bottom separately and then see if you can cancel anything. What's nice is there's no number in front of the squared term, so you can use the short version, multiply to get a 9, and add to get a -6. So what 2 numbers can we multiply to get 9 and add to get -6?
3 and 3.
And we'd want both of them to be negative. So it would be x minus 3 and x minus 3. We're using the 2 negatives so that we get that -6. And how about the second, or the denominator? What 2 numbers multiply to give you 3 and add to give you 4? Anyone?
3 and 1.
Mm-hmm. When we multiply, we get the positive 3. When we add, we get the positive 4. So x plus 3, x plus 1. Okay. I thought one was going to come out. Fact cancel. Got it out of your book, but it's not. Because these are both negative, it will not cancel with this one. And so this does not reduce. Let's do another one. X squared minus 4 and 3x plus 6. Now let's try this one. Was there any questions on this? If any of these factors would have been exactly the same, then we could have canceled, but none of them were. Okay. This one, I think we did this factor, but they're both perfect squares. And so this would be x squared plus 2 squared minus 2 squared. So this one's the difference of squares. Dropping the squared, you have x minus 2 and x plus 2. In the bottom one, it's not squared, but we can factor out a 3 because it has a 3 in common. And if we pull that 3 out, we're left with x, and when we pull the 3 from here, 2, so x plus 2. And these two cancel and leave x minus 2 over 3. Any questions on that one? Any questions? Why that keeps going blurry. Okay, x plus 3 over 6 times 2 over x minus 3. Remember when we're multiplying fractions, we just multiply across. Now, if you want, you can simplify first, as long as it's something from the top and the bottom. These two binomials will not cancel because they're not identical. But the 2 and the 6 can reduce by 2. Now, if you're not sure, what I recommend is instead of distributing, just write it. We need 2 times x plus 3 and 6 times x minus 3. This is a little easier to see the reducing because we can divide by 2. So we have x plus 3 over 3 times x minus 3. Any questions on that? Any questions on the multiplication one? Now, the difference between the multiplication and the division, when you're dividing fractions, you change it to a multiplication. So to do that, you flip the second fraction and multiply. That means it would be the first one stays the same, and then it becomes a multiplication and you flip this one. Then you just use your same rules for multiplication. Now, notice an x plus 2 in the top and the bottom. You could cancel those first if you wanted, or you can multiply first. 6 times 2 is 12 times the x plus 2 over 5 times the x plus 2. And the x plus 2's are the same, so they cancel. 12 and 5 do not reduce, so it stays 12 fifths. Any questions on that? So when you have fractions, if you're multiplying, multiply crossed. If you're dividing, make it a multiplication by flipping the fraction after and then just multiply. Any questions on that? Positive. Okay. It is 10 till. Is there any questions on anything? All right, so Friday will not be a group assignment. We will finish reviewing all the problems. I recommend going through, you could do the half that we've done today. And then if you want to go further, if there's ones you know, you could go ahead and get them done ahead of time because they are due on Sunday at 11:59 p.m. And if you don't have any questions, I will see you on Friday. But if something happens and you got a question, let me know. Have a nice day.
Thank you. Thank you.
Thank you for coming. Have a nice day.